Take a chocolate bar and break it in half. You haven't changed what it is, only how much you have. Chemistry asks the same kind of question all the time, not what substances are present, but how much of each one. That's what quantitative analysis is about. Let's go a little deeper. Quantitative analysis focuses on numbers. It measures masses, ratios, and proportions to describe chemical composition accurately. One common idea is percentage composition. It tells you what fraction of a compound comes from each element. For example, a compound might be 40% carbon, 6% hydrogen, and 54% oxygen. Those numbers describe the substance, no matter how big or small the sample is. But wait, here's the twist. Knowing percentages still doesn't tell you how atoms are arranged. That's where empirical formulas come in. An empirical formula shows the simplest whole number ratio of atoms in a compound. It doesn't tell you the exact structure, just the basic building ratio. Here's something even more interesting. Different compounds can share the same empirical formula but behave very differently. So quantitative analysis gives you the foundation, not the full picture. Let's connect this to real life. Food labels list percentage composition. Material testing depends on exact ratios. Industries rely on precise calculations to avoid waste and ensure safety. All of this works because chemistry follows strict numerical rules. Before we wrap up, zoom out for a moment. Quantitative analysis turns chemistry into something measurable, predictable, and reliable. It's how chemists move from observation to precision. And that leads to the next question. If chemistry can be measured so accurately, how does it help us understand reactions happening in the environment around us? That's exactly where we go next.